Welcome to Function Focus, Lesson 18 with Miss Barrett. First off, let me say I apologize for the late post, but I had some technical difficulties that needed to be resolved before I could record and post. The good thing is, however, that you have also Tuesday and Wednesday to kind of look at these this video and get some notes done. So we're starting our unit on logarithmic and exponential functions, starting off with exponentials. Today we're going to discuss arithmetic and geometric sequences. So our objective is hopefully by the end of today, students will be able to write an explicit formula for an arithmetic and geometric sequence. Okay, so your homework will be, or your practice will be sequences worksheet that I will actually show you, that hopefully you'll be able to have some time to get that done. I will go over the answers to that practice on Wednesday's video. So let's start with arithmetic. So if you look at the word arithmetic, it has the word arithmetic in it. And arithmetic literally means to add and or subtract. So when you have a sequence, and a sequence is just an order of numbers, right? So a sequence can be an order of numbers, a sub 1, which is the first term, a sub 2, which is the second number, a sub 3, all the way to a sub any number. So we use that n. So this is the a sub 1 is the first number, a sub 2 is the second number, a sub 3 is the third number, and so on and so forth too. We can have as many numbers as we want, and we'll call that n amount of numbers. So we'll use n to say that it's the nth number or it's the nth term in the sequence. Okay, so that's a sequence, it's the order of numbers. An arithmetic sequence, however, is when there is a constant difference, or let's say the difference between, I want to underline that word difference, between consecutive, means one after the other, between consecutive terms are the same. That's fancy for saying when you add or subtract the same number each time. When add or subtract the same number each time. Okay? When you add or subtract the same number each time, that's when you have an arithmetic sequence, which I'm going to give you an example. But for example, let's say this first term is 1, this second term is 3, this third term is 5. You would say you're adding 2 each time. Okay? That's how you know it's arithmetic. That's how you know it's arithmetic. So let me actually give you that example. So an example is, if my first term, let me give you a different example. If my first term is 0, my next term is -3, my next term is -6, okay? Each time you're subtracting 3. Okay, so it's -3, right? So that means the difference between 0 and -3 is -3, or subtracting 3. The difference between -3 and -6 is -3. Okay, so it's subtracting 3 each time. Okay, it could also be adding 3 each time if I gave you that kind of example. So it's when you're adding or subtracting the same number each time to get from one number to another. That's an arithmetic sequence. Okay. You can find if it's arithmetic easily by saying, if you have your second term, your a sub 2, and you subtract your first term, it should equal what we call D, the common difference. Okay? Now, if you take your third term and subtract your second term, you should get the same number. Okay? Okay, we call this the common difference. That D is the common difference. That's the number that you're adding or subtracting the same every time. Okay? So here, if I had my second term here is -3. -3 minus 0 is -3. -6 minus 3, -3 is -3. So I would get -3 each time. Therefore, my common difference would be -3. I'm going to show you more examples of this. So we have two equations that we use, or two formulas that we use to help us find any term in a sequence. To help us find any term in a sequence. We call them the recursive and the explicit. Okay? Now, the recursive is something that is used, but we're not going to use as much here. Here, the explicit is going to be the more important one. Okay? So the recursive formula is a sub n, or finding any term in a sequence, equals the previous term. So the previous term, any term, so a sub n means the nth term in a sequence, any term. So n can be anything. Sequence. I have to learn how to spell. Okay, so a sub n, any term in a sequence, right? N is the term you're looking for. Okay, the term you want. So n could be the n. If n is 1, it's the first term. If n is 2, it's the second term. If n is 3, it's the third term. If n is 100, it means what's the 100th number in the sequence. Okay, so we want to know what's the, let's say, the 100th term in the sequence for recursive equals the previous term. So a sub n minus 1 means the previous term plus the common difference. And we just learned that the common difference is whatever you're adding or subtracting by each time. Okay. More importantly, the explicit formula, if I want you to find, let's say, the millionth term of a sequence, that's going to equal a sub 1. A sub 1 is the first term. Okay. A sub 1 is the first term. Okay. Plus the common difference, which you already know what D is, times the term you want, which would be n. So this n and this n would be the same, minus 1. Okay. So you always first have to figure out, is this an arithmetic sequence? And I'm going to show you how to do that. And then once you find out if it's arithmetic, you can write the recursive and explicit formula by just plugging in what you know. Let me give you an example. So here, number 1, they give me my first 3 terms. So this is a sub 1, 19. A sub 2 is 14. A sub 3 is 9. That's the first term, the second term, and the third term. Okay, so I need to know if it's arithmetic. So first I need to say, well, what are they adding or subtracting by? So from 19 to 14, I'm subtracting 5. Okay, from 14 to 19, from 14 to 9, I'm also subtracting 5. I could have also found this out by doing this. 14 minus 19, like we did up here. A sub 2 minus a sub 1. Then a sub 3 minus a sub 2. That's going to give us our common difference. So 14 minus 19 is minus 5, or negative 5. And then 9 minus 14 equals negative 5. So my D is going to be negative 5. I took my second term and subtracted my first term. Then I took my third term and subtracted my second term. And they gave me the same number. So my common difference is negative 5. I'm subtracting 5 each time. My first term is 19. A sub 1 is 19. Once you find those two terms, now you can plug in what you know into the recursive and the explicit. Okay, so let's look. We know the recursive is A sub n equals A sub n minus 1 plus D. So we don't know what term we're looking for. So we're just going to put A sub n equals, I'm going to plug in only what I know. And what I know is that A sub 1 is 19 and D is negative 5. So my formula says A sub n equals A sub n minus 1. Well, I don't know A sub n minus 1, so I'm just going to rewrite that. You only plug in what you know. But I do know that my D is negative 5. So it's A sub n minus 1 minus 5. And you have written your recursive formula. The recursive formula is pretty much easier because for the sake of what we're learning today, all you know is your D if you're dealing with an arithmetic sequence. So really all you have to plug in is your D. The explicit formula, however, is a little bit more complicated. So we know the explicit formula is, we want to know the term that we're looking for equals the first term plus the common difference times n minus 1 times the term we're looking for minus 1. Okay, so we're going to plug in what we know. That's the first thing you do. Plug in what you know. We don't know A sub n. We're going to keep that the same. Equals the first term. We know the first term is 19. So we're going to plug in 19 plus the common difference. But because the common difference is negative 5, we're going to subtract 5. And that's going to be multiplied times n, which we also don't know, minus 1. Everything in green here is what I know. So it's only two things I can plug in, the first term and my common difference when we're dealing with the explicit. Okay. Now, in order to simplify this, we're going to distribute. So I'm going to rewrite this. A sub n equals 19 minus 5 times n minus 1. So the first thing you're going to do here, we're going to distribute this 5 to the n, and we're going to distribute that negative 5 to the negative 1, which is going to give us A sub n equals 19 minus 5n plus 1, because negative 5 times n is negative 5n, and then negative 5 times negative 1 is, positive 5. You see that? All I did was distributed a negative, and you have your steps over here. Okay. Now I'm going to simplify that because I can combine my like terms. So if you want to put combine like terms, we do that a lot. Okay. So I'm going to combine 19 and 5. So my answer is going to be A sub n equals 19 plus 5 is 24. 24 minus 5n. And this is my equation right here. So now I have my explicit and my recursive equations. Okay. Again, all we did was we plugged in what we knew and we simplified. Let's do another example. Example number 2. My sequence, my first three terms, A sub 1 the first term. Remember, this could be an n. So here, n equals 1. So this is the first term. A sub 2 is 1, the second term. And then a sub 3, or my third term, is 19. Okay. So how did I get from negative 17 to 1? Let's look. So I'm going to take my a sub 2 to find my common difference, my a sub 2. So a sub 2 is 1. And I'm going to subtract negative 17. And that's going to equal, these become two negatives make a positive. This becomes 18. So my common difference so far looks like it's 18. Let's do the next one. My third term minus my second term. So it's 19 minus 1. That equals 18. So that means my common difference is going to be 18. Again, you do your second term minus your first term, and then your third term minus your second term. Okay, so second term minus your first term, third term minus your second term. And you should get the same number. That's your common difference. Your first term is easy. It's just the first number in the sequence. So my a sub 1 is negative 17. Now, I'm going to plug what I know, which is negative 17 for a sub 1, and d equals 18. I'm going to plug it into my recursive formula. So recursive formula is a sub n equals, so the term we're looking for, which we're not looking for any specific term here, we're just creating the formula. A sub n equals a sub n minus 1. Because if we don't know what term we're looking for, we surely don't know the previous term, plus the common difference. So it's going to be plus 8. Plus 8. 18, I'm sorry, plus 18. So that's the recursive. We're done in the recursive. The only thing we can plug in is our common difference. Now, explicit is a little different. Okay, so we know our explicit formula is a sub n equals a sub 1 plus the common difference times n minus 1. And again, n means the place of the term we're looking for. So if I was looking for the 100th term, then n would be 100. Okay, so for the explicit, we're going to plug in what we know. We're in that second step. Plug in what we know. We don't know a sub n. But we know a sub 1 is negative 17, the first term. And then we know that our common difference is 18. We do not know what term we're looking for, and the minus 1 is just part of the formula. Okay. So now we plugged in what we know. We now must distribute. Distribute 18 times n, 18 times negative 1. That's going to give us a sub n equals negative 17 plus 18n minus 1. All I did was distribute. Now, let me combine like terms. Negative 17 and negative 1. It's going to give me a sub n equals 18n minus 18. Okay, all I did was combine like terms. Now, if you notice, I wrote these two differently. This one says 24 minus 5n. This one says 18n minus 18. It's all the same. However you write it, ladies and gentlemen, I do not care. You put the n term in front or the constant term last, it doesn't really matter. Okay, as long as you follow these steps and you do your calculations correctly. All right, so now I have my recursive and my explicit. Again, the explicit one being a little bit more involved. So now using these two examples, I want you to try to do 3 and 4 on your own. Take a minute, pause this video, and try to do 3 and 4 on your own. Okay. All right, now number 3. So I have my first 3 terms in my sequence. I want to know what my common difference is. First off, let me say the first term is 8. So I know automatically a sub 1 is 8. Doesn't require any math. Now, what does require math is me finding out what my common difference is. What are they adding or subtracting by each time? So I'm going to go to my second term, 11, and I'm going to subtract the first term, minus 8, equals 3. Then I'm going to go to my third term, 14, and subtract my second term, minus 11 equals 3. So my common difference here is going to be positive 3. Now I have two things that I know. I know my common difference is positive 3. I know my first term is 8. Now for recursive, I'm just going to plug those two things in. Or actually what I know, what matters for the recursive, I'm going to plug it in. So recursive says a sub n equals a sub n minus 1. Those are two things we don't know. And I do know my common difference. I'm just going to plug it in, plus 3. And I'm done. I'm done the recursive. For the explicit, I have to plug in my first term and my common difference. So it's going to be a sub n equals, the first term is 8. Plus my common difference is plus 3. So everything in green is what I know. And then I'm going to finish off my formula, n minus 1. So I'm going to rewrite this. A sub n equals 8 plus 3 times n minus 1. And now I'm going to distribute that 3 to everything inside the parentheses. So it's going to be a sub n equals 8 plus 3n minus 3. All right, all I did was distribute that 3. 3 times n is 3n. 3 times negative 1 is negative 3. Now I'm going to combine like terms and simplify. A sub n equals 8 minus 3 is 5. Okay, plus 3n. This is now my explicit formula. Now all I have to do is somebody give me an n. If I say what's the 100th term, then you would say n equals 100. If I say what's the 5th term, then you would say n equals 5, and you would plug 5 in wherever you see n, and you would solve it. We'll see that later. Okay, next up, 54 is my first term, 45 is my second term, 36 is my third term. So clearly 54 is my first term. Let's find our common difference. So I'm going to take 45, which is my second term, and I'm going to subtract 54, which is going to equal negative 9. So we know that the second term minus the first term is negative 9. Now we have to know that we have to figure out if the 36, which is the third term, minus the second term, 45, is also negative 9, which it is. So that means our common difference is now negative 9. So now we have two items we know. We know our first term is 54. We know our common difference, or what they're subtracting by each time, is negative 9. So for the recursive, we're going to plug in what we know. A sub n, we don't know that. We're just going to rewrite a sub n. We don't know a sub n minus 1. But we do know that our common difference is negative 9. So I'll just plug that in. And then that's my answer for recursive. Again, I told you, recursive is the easy one. We won't be using it as much as we will be using the explicit as well. So now for explicit, I have a sub n equals a sub 1, the first term, plus the common difference times n minus 1. So I'm going to plug in what I know. A sub n, don't know that, equals, well, a sub 1 on my first term is 54. Plus my common difference, which is actually subtracting your common difference this time because your common difference is negative 9. And then multiply that times n minus 1. Okay. Now we have to distribute. We plugged in what we know. Now distribute. A sub n equals 54 minus 9 times n is negative 9n, and then negative 9 times negative 1 is plus 9. Combine like terms. A sub n equals 54 plus 9. Okay, 54 plus 9, which is going to be 63, minus 9n. And that is my answer. I cannot simplify it anymore. Okay. Now, on your homework or on your practice, I will ask you to find the 10th term. So let's say, for example, for this third problem, I say, now what if n equals 10? 10th term. Find the 10th term. That means n is 10 now. So I want you to find the a sub 10. Okay? A sub 10 equals what? So you're going to plug it in. So a sub 10 equals 5 plus 3 times 10. Okay? Because n is really the only variable we have left. So if I say find the 10th term, you're just going to plug in 10 wherever you see n. And that means that a sub 10 would be 5 plus 10 times 3 is 30. That would be 35. Okay? So you can use these formulas to find any term in the sequence. Okay? We only were given three terms here, but I was able to use this formula to find the 10th term. You can use that formula to find the 100th term if you want. The 1,000,000th term just might take a little bit more calculations. All right, so that was arithmetic sequence.